Okay, hello, dear students of year 9. Um Today we are going to make a review of all the properties and all the lessons that we have been doing this second part of the second trimester. We are going to review a little bit about the congruent triangles, um, similar triangles, or similar shapes in general. So, in order to start, we need to remember all these four conditions that we can follow in order to check if we want to prove that two triangles are congruent. In other words, when two triangles are congruent, they are the same, but the position changes. So we have this one side by side. As in class, we call it when the three sides are the same, we have the same triangle. Triangles are congruent. We have SAS, side angle side, which means two sides are included, and we have the angle in the middle. As you can see here, the angle in the middle of the two sides are the same. We have ASA, which means angle side angle. Please make sure that now you have two angles. As you can see here, you have two angles which in the middle they have this side which is the same, and the last one RHS, which means right angle hypotenuse on one side, which states that whenever we have the same hypotenuse, the same side apart from the hypotenuse, and of course, as the name is saying, the right angle, like you can see here, these two triangles are going to be congruent. So, in order to, this is very good. This is being recorded. Okay, so we are going to practice with some of these triangles right here. This first one, as you can see, we have an hypotenuse side, which those triangles have in common. We have another side which these two triangles have in common, and we have the right angle. So we have, as you can see, the right angle, which is we have the R, the right angle, and the hypotenuse, and one side in common. So as we can see, we are following this condition. The hypotenuse is the same, is the thing in common. The other side is the other side in common as well, and we have the right angle. So we can say that for this condition, these two triangles are the same. Here we need to check what do we have. We have one side, okay, and this side, if you realize, is between two angles. We have this angle here and this angle here, and if you realize this angle here and this angle here is between, we have this side between these two angles, and here we have the same. So if we have two angles and in the middle we have the same side, this is going to be angle side angle. And if you realize, the side should be in the middle. As you can see here, angle side angle, the side should be in the middle, which is something very similar to the following one. If you realize, we have two sides, and in the middle, what do we have is the angle. So, what do we have here? We have side, angle, and side. And if you realize, we can check in this other one, we have the side, we have the angle, but stop right there. If you realize the other side should be here, right? Not here. So, as you can see, what do we have here? We have two sides and the angle is not in the middle. So, here I can see that these two triangles are not congruent. Not congruent. Because the condition says that between the two sides we should have the same angle. And unfortunately here, between the two sides we don't have anything. And neither here we have one side and here we are supposed to have the other side, but we don't have it. So these two triangles are not congruent. Right here what do we have? We have two triangles, and if you realize the only difference is that they look connected with this linear, with these lines right here. So what we can do here, if you realize we do have this, and in the middle we have the angle, right? The same is happening right here. We have this side, which is the same as this one, and we have this side, which is the same as this one, and in the middle what we have is the same angle. The same angle. If you realize angles are represented by how many lines. For example, here this angle can be this one, and this other angle, which I put like two lines, can be this one. So as you can see here, what is the condition uh, well, we are following is this one, side angle and side. Please make sure that the angle is in the center. Okay, well, not in the center, between the two sides. And here we can see that the angle is between the two sides for both triangles. So we can say that for the condition side angle side, these two triangles are congruent. Here what do we have? We have hypotenuse. Every time you have hypotenuse, this is mostly like to appear. We have the hypotenuse, we have one angle, okay. But if you realize, even though we have the same hypotenuse and we have an angle that they are in common, unfortunately we are not following any of the other conditions. But this has something that I need to make clear. Even though these two angles are the same, just to make sure, well, make sure you to remember, if you do remember, every right triangle, if for example here is 90 degrees and here you have, let's say, 50 degrees, here I will need 40 degrees in order to complete the 180 degrees that all triangles have inside, like the sum of all the inside angles of a triangle should be. So just to make clear, just because this triangle is telling me, okay, this is 90 degrees and this is 90 degrees, let's suppose if this angle, let's say, is 50 degrees, the angle right here will be well, 50 plus 90 would be 140, and in order to get to 180 I will need 40 degrees, and it's going to be the same situation right here. So the good thing about this is that these two angles are going to be the same. So this is quite a tricky question. Even though the original drawing isn't showing you that those angles are the same, they are going to be the same. So this is like quite a good question for a test. Now, if you realize, now we are following one of the conditions. We have the angle, one side, and an angle as, and the same right here. We have the angle, the side, and the angle. Let's move on. Now right here, what do we have? The same, we have angle, side, angle. Angle, side, angle. As well. Right here, we have three sides. We have side, side, side. This is one of the easiest ones. When all the sides are the same, of course, these triangles are going to be congruent. And they might look, the 7 and the number 8 might look different, but in fact they are the same. Why? Because even though we have these two sides which are in common and these two, the third side is being shared. The third side of course is going to be the same for them. So because we have the three sides the same, we have this side, and this side, these three are going to be the same for this other triangle. We can conclude that these two triangles are going to be congruent. And we are finished. Now moving on, we have to, we are going to look to this next topic. The next topic it was similar figures, but today we are going to do only similar triangles. Of course, this topic is not only for triangles. We have a lot of shapes that we have done even in class. For example, shapes like quadrilaterals, which are, they look like this. They follow quite the same characteristics and properties which are shown here. Now, just to remember, similar triangles or similar figures, the difference that we have between congruency of triangles and similar triangles is that triangles right here, they are exactly the same size, okay? The same size. Maybe only the position changes, but they are the same size. The difference is that here they are not the same size, but they are similar. It's like the small and the big version of a shape. Now, all these properties we have done in class, but we have to remember that when we have similar triangles, they can follow one property. This one. This one is the most important one and the one that you are going to follow. For example, if this triangle, which the sides are marked as C, B, and A, C, B, and A, well, A, B, C, are divided over these ones, which let's say these two are similar, they are going to give me always the same result. The same if we do these two, or even though the same if we do, here, even though if we do these two, they are always going to give me the same result. Now, in order for you to remember, I will give you one example. Let me erase this to make this much clearer, okay? Let's say that this triangle is 3, this is 5, and this is 4. And let's say that for this other triangle, this is, well, I will use other numbers. This is going to be 10, this is going to be 6, and this is going to be 8. I think this is much better. Let's say that for this triangle, and the one right here, let's say that this is going to be 5, this is going to be 3, and this is going to be 4. If you may realize, the only thing is happening is that each side is being multiplied by 2. But let's follow the property. The property is saying, okay, the side A, which in this case is 6, being, if you divide it by D, which in this case is 3, it's going to be equal, here I will write other fractions, it's going to be equal to B, which is 10, divided by divided by E, which is 5. And we have the last one, which is C, divided by, well, we have C divided by 4, which is F, right? 6 divided by 3 is going to be 2. 10 divided by 5, it's going to be 2 as well. And this is going to be 2. So, as you can see, this always is going to work for similar triangles. They are the same. They are going to give me always the same result. So, in order to practice this, we have these two exercises. Okay? So, let's go to another page. We are going to work this out. Okay, for the following one, you may realize that it's almost a complete triangle, but we are missing two sides. And of course, we need to find what is the value for these two sides. So let's go back here and remember this property. ABC are the sides of the big triangle, okay? So we have the sides of the big triangle right here. It's going to be divided by the sides of the small triangle right here. And I don't have to choose any side. You have to remember that we have to, if we are going to divide this side, which is related to this one, we have to divide this one, which is related to this one, and this one related to the other one. We cannot mix the sides with another, because if I choose the big size divided with the smaller one, and the smaller one divided by the big one, is not going to make sense. These ones are attached, they are related. It's the small version of the older triangle, so we need to be careful with that. The same happens here. If you realize these triangles are quite related. For example, this side y is related to this one, right? This side x is going to be between these two sides is the smallest, so it's related to this one. And lastly, we have this one, 20, which is related to this side. Now, following the properties that we have been doing, we are going to divide the big size. We are going to divide them between the small size. So we have the following thing. We have y. We are going to divide it by 13, and this is going to be equal to 20 divided by 10, and this is going to be also equal to x divided by 8. You may realize that I can simplify this, and here my answer will be 2. Right? Now, of course, working with these three things, we have equal and equal, we need to make pairs, okay? For example, this, I will work it alone. Y over 13 equals 2, okay? And I will take this other to work them alone as well. Now, here, if a number is dividing, goes to the other side to multiply, so it's going to be 2 times 13. And here the same. So what is going to be the value? 26, and here the value is going to be 16. And we are done with that. you have the answer for this one. Okay, now this is a secret, and this is just in case you are watching the video, so please be careful with that. This exercise is going to be for extra points. If you do this exercise, apart of giving you 5 extra points, you don't have to present the homework. But this is only a Easter egg for you. That's everything for today. I hope you, if you got any questions, see you in class. This was Mr. Ray.